Hi, questions in mechanics. In this textbook, problem 4.34. An interesting one-dimensional system is the simple pendulum consisting of a point mass m fixed to the end of a massless rod length L, whose other end is pivoted from the ceiling to let it swing freely in a vertical plane, as shown in this figure. The pendulum's position can be specified by its angle phi from the equilibrium position. Prove that the pendulum's potential energy is given by this equation. Write down the total energy E as a function of phi and phi dot. Show that you can get the equation of motion for phi, and that the equation of motion is just the familiar this one. Assuming that the angle phi remains small throughout the motion, solve for phi t and show that the motion is periodic with this period. Solution. We get the potential energy and the total energy. We have this equation. This gives this equation. Then we get this result. For the case phi small, we have this equation. Then we conclude this result. Problem 4.35. Consider the Atwood machine of this figure. But suppose that the pulley has radius r and a moment of inertia I. Write down the total energy of the two masses and the pulley in terms of the coordinate x and x dot. Obtain the equation of motion by differentiating the equation E equal constant. Check that the equation of motion is the same as you would obtain by applying Newton's second law. Solution. We get this result. By conservation of energy, we obtain the equation of motion. Applying Newton's second law, we get the same result. Thanks for watching. Bye.